Question 6. A ball is thrown with a velocity of 15 meters per second at an angle of 30 degrees to the horizontal. You may assume the launch is from ground level. Calculate the time of flight, the range, the maximum height. Start by drawing a diagram of the setup. We've got some level ground. We've got a ball launched at 15 meters per second at an angle of 30 degrees, travels through the air and hits the ground. This distance here is known as the range. So this is a projectile motion question that starts by us needing to resolve this vector. I'm going to put some more space in because I don't think I've left enough. So we'll start by resolving the vector. So 15 meters per second with an angle of 30 degrees down here at the bottom. This we can resolve into two components. I'm going to label this one as VH, that's the horizontal velocity, and this one as V subscript V, that's the vertical velocity at launch. So VH has a size of 15 cos 30, whereas V, the vertical velocity, has a size of 15 sine 30. So this gives us a value of 13 meters per second, and 15 sine 30, of course, gives us a value of 7.5, doesn't it? Of course it does, 7.5 meters per second. So when we're finding the time of flight, the only thing that matters is the vertical velocity. We can now use our Suvat equations. So I'm going to switch color. Let's go to this orange and think about the Suvat equations in the first part of the question. The displacement between it being launched and returning to ground is 0 meters. The initial vertical velocity is 7.5 meters per second. This is happening on Earth, and therefore the acceleration is minus 9.81 meters per second squared. And we want to find t, the time of flight. So we can use the equation S equals ut plus half at squared. I'm going to move this down again and still run out of room. So we're going to rearrange this for t. We can see straight away that S is equal to 0 though. So to make our rearranging easier, I'm going to divide both sides by t. This side is 0 divided by t. We can get away with not writing the divided by t on the left-hand side. Now my equation is much simpler to deal with, because when I rearrange it, I can write t. So I'm going to get S minus U initially, and I'm going to multiply both sides by 2 and divide both sides by A. So the time should be 2S minus U over A. This is 2 lots of 0 minus 7.5 divided by minus 9.81. So that's minus 15 divided by minus 9.81, which gives me a time of flight of 1.5 seconds. So two significant figures. The range, I've given myself lots of space, but relatively straightforward. In the horizontal direction, it travels at a constant speed because there's no forces acting in the horizontal direction. The horizontal speed is the horizontal velocity that we calculated at the start, 13 meters per second. And it travels for a time of 1.5 seconds. So we're just going to use the idea that distance is equal to speed times time, if you like. S is equal to ut. There is no acceleration, so we won't bother with the half at squared part. That's 13 times 1.5, which is 19.5 meters. And last part, the maximum height. So we're back to dealing in the vertical direction. There's a couple of approaches. One approach might be to say that the time at which it reaches maximum height is half of 1.5. I think the way I look at it is the more rounded values you use, the greater chance there is that your rounding is going to cause a problem with the final value you get. So I think what we should say is that we know in the vertical direction, we have an initial vertical velocity of 7.5 meters per second. We have an acceleration of minus 9.81 meters per second squared. And that we know the final velocity. So really, I want a U here, don't I? This is the initial velocity in the vertical direction. The final velocity in the vertical direction is 0 meters per second. That's when it gets to the top of its flight. I'd like to know the displacement when it gets to the top of its flight. So I'm going to use the equation v squared is equal to u squared plus 2as, rearranging for s. Pen stop working. There we are, we're back. Rearranging for s, we get s is equal to v squared minus u squared over 2a. V is 0, so 0 minus 7.5 squared divided by 2 times minus 9.81. Which gives us a value of 2.86, so 2.9 meters.